Our next unit of study in physics this year is momentum. And we're going to do a lab like we typically do before we get into the equations and so on of the unit. But this time, before we do the lab, I have to teach you a little bit about the concept first. So the definition I'm going to give you for momentum is just not a good one. There's no good way to define momentum. So the best I can come up with is mass in motion. The definition of momentum is mass in motion. But the good news is the way that people use this word every day is pretty close to what we're talking about in physics too. For instance, you might say that our boys soccer team has a lot of momentum right now because they've just won 2 games by a big margin. So they have momentum going into the state championship this weekend. That's the same idea that we are talking about in physics. It's the same type of use that you use in everyday language. But you need to know the equation for momentum before you can do this lab. So here it is. The equation for momentum is P equals mv. And in this equation, the P stands for momentum. Kind of strange, I know, but that's what it is. M is for mass, and V is the velocity. So here's where you see what I mean by mass in motion. We're talking about the mass of an object and its speed, or its velocity. The bigger the mass, the bigger the momentum. The bigger the velocity, the bigger the momentum. The units for this are just like you might expect. Mass is measured in kilograms. Velocity is measured in meters per second. So momentum is measured in kilogram meters per second. It's not renamed like the Newton was, it's just plain old kilogram meters per second.